All right, so today we will talk about crashing a project. So we're continuing this topic from chapter 3, project management. We have already, up to this point, learned how to find the critical path. So we have done the critical path analysis. We have done the forward process to find the time of completion of each task, total time, overall time to complete this project is 15 weeks. That's our estimation. And we learned the backward process as well. So what we're going to do next is we're going to learn how to crash a project. Factors to consider when crashing a project. The amount by which an activity is crashed is, in fact, permissible. Taken together, the shortened activity duration will enable us to finish the project by the due date. The total cost of crashing is as small as possible. Steps in project crashing: compute the crash cost per time period. If crash costs are linear over time, right, then we can calculate it using this formula. Crash cost per period is crash cost minus normal cost divided by normal time minus crash time. Using current activity times, find the critical path and identify the critical activity. So remember, whenever a question is given to you, and maybe the question is just asking you to crash this project. So the first step is to make sure you know the critical path, because when you want to crash a project, you need to crash those tasks that are on the critical path, and among those tasks, you take the one that is crashable using the lowest cost. Step 3, if there is only one critical path, then select the activity on the critical path that can still be crashed. That means there is time for activity that we can reduce it by 1. Has the smallest crash cost per period. So we're looking for the lowest cost. If there is more than one critical path, then select one activity from each. So if you have 2, if you have 3 critical paths, right? More complex problems might have 2 critical paths. If that happened, you need to crash both at the same time by 1 activity. So, and of course, on each critical path, you select the lowest cost. Each selected activity can still be crashed, and the total crash cost of all selected activities is the smallest. Note that the same activity may be common to more than 1 critical path. And lastly, after you did the crash, meaning that you reduced the time of completion of one of your projects, one of your activities, then you need to recalculate all activities from the beginning, okay? So update all activity times. If the desired due date has been reached, stop. If not, return to step 2 and continue. So let's look at some example here. So in that example, we have information like normal time. That is normal time it takes for us to complete the activity, and the crash time. So the crash time, activity A can crash by 1, B by 1, right? And then what's the cost of crashing 1 week on A? It's from 22,000, it's up to 22,750. So the crash costs, just subtract them. And the difference of the weeks is just 1 week, so divide by 1, $750 per week. Is A on critical path? Yes. Do we check for B at this point? No. Why is that? It's because B is not on the critical path. So we're not going to crash B. C is, it's an option, but it's more costly. So we don't choose. We chose A because A has 750. So calculating the crash cost, you can see here, if we reduce 2 weeks instead of 1 week, go with 2 weeks, then $34,000 minus 30,000. 34,000 is the crash cost. This is the normal cost. The difference is how much you have to pay to crash. And what is that additional cost for? This is normally for adding machines to speed up the process or hire some new employees to complete the work faster. Difference of the costs from normal to crash is $4,000. We're crashing 2 weeks here. That's $2,000 per week. So let's say the question says, reduce project completion time by 2 days. Recalculate all after each crash. Let's look here. So what I did here, I just copied and pasted the network that we had, already calculated the numbers, and I just added the slacks. Slack is 0 here. How do I know slack is 0? 2 minus 2, or 0 minus 0 is 0. 4 minus 4, 0. You can see those activities that are on critical path, they have a slack of 0. Others are not, because they are flexible. They have weeks actually to crash. But the thing is, when you want to reduce the total activity time of your network or your project, which of these is the most important? The most important is your critical path, because that's the maximum time that it takes for us to complete this project. As a result, we have to find our crashing activity from the critical path. So, and I just told you on the critical path, A is the one that you can crash. And we want to crash by 2 weeks, right? This is 2 weeks. And then we are going to recalculate everything. And what I did, I just copied and pasted the table here, so we can look at these costs of crash. This way, this helps us to, we don't have to go up and down on the slides. So again, I did duplicate this slide, put it here, and just change the numbers, right? That's all you have to do. So you want to go for starting with the crashing task A, and just by 1 week, because it's the lowest cost and it's on the critical path. So activity A is going to be crashed. So what I did was actually like this. It was 2. So I changed this 2 to 1. 1. 0 plus 1. 0 plus 1 is 1. Right? 0 plus 1 is 1. So 1 goes there. 1 plus 2 is 3. So this is going to update all others. First, select and change the activity you are supposed to change or crash. I crashed this from 2 to 1. Now it's 1. Now I need to update the whole network if required. So look, C changes as well, reduces by 1. F also changes. It was 7 and 13. Now it has reduced to 3 plus 3 is 6. So moving forward first and then moving backward, right? Same process that we learned before. And also here, 3 goes there. 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 2 is 14. 12 plus 2 is 14. Now backward. For both sides, 14 minus 2 is 12. So 12 goes here. 12 minus 3 is 9. Here, 12 minus 5 is 7. For this activity E, 7 goes there. That 7 goes there. 7 minus 4 is 3. 3 minus 2 is 1. So this is correct. 1 minus 1 is 0. How about here? 12 minus 5 is 7. 7 minus 4 is 3. 3 minus 3 is 0. And that's the starting point. So as you can see, now we have two critical paths. How it happened? On this path, initial path, all these activities, they have slack 0. And here also now we have a slack of 0. So I change this to 0, 0, 0, 0, right? So we have two critical paths now. We have already reduced, right? We reduced the project by 1 week and did the recalculation. What was the cost of it? Cost $750. So with $750, we could reduce this cost. Now, what I do, I just duplicate this slide or copy and paste the same slide and change the numbers for the next step. For the next step, look here. On the critical path 1, which one has the lowest cost? A, 750 is the lowest. On critical path B, G is the same for both sides. So we don't want to change, we don't want to touch that at this point. So between B and D, B is $2,000, D is $1,000, and G is $1,500. So which one is the lowest? Of course, the D. D is $1,000, right? So we select A from, you remember the process or the step set from each critical path, select the lowest cost activity and crash it similarly. So we crash one from this and one from the red color, one from the blue color, and one from the red color. From red color, we selected D because it has the lowest cost, 1,000. From blue color, we selected A because A had the lowest cost, $750. So copy this down here. Now, we're going to crash A and D by 1 week, one more week. The lowest cost here is $750. After reducing on A and D, we're going to recalculate everything. Okay, so we're recalculating everything. And I updated the slacks. And we can see that we have to have the recalculation down here. So we will recalculate after crashing. So let's crash A by 1 unit. Goes down to 0. So immediately A can be completed if we spend another $750. And D reduced by 1. This is 3. 3 plus 3, 6. So I just updated the top part. 6. And we can update the bottom part. It has to stay, and we'll update it backwards. Okay, so let's update the whole thing. This is 1, this is 0. So this can be start at the beginning, 0. 0 plus 2 is 2. Then 2 goes here. 2 plus 3 is 5. 2 plus 3 is 5. And then from here, 2, so put 2 here. 2 plus 4 is 6. And then 6 goes here. You can see that here is also 6. 6 goes here. 6 plus 5 is 11. 11 and 11. 11 plus 2 is 13. Now backward, the 13 goes here because that's the maximum. 13. 13 minus 2.
Sir.
All right, so we are 7 minus 4 is 3. This is correct. And then 3 minus 2 is 1. So did I change this? No. So 6. Because we are using the 12 minus 5 is, so this is, sorry, 13 minus 2 is 11. And then 11 goes here, minus 2, minus 3. 11 minus 3, 8. And here also 11 minus 5. 11 minus 5 is 6. Okay, 6 goes here. And 6 goes here as well. 6 minus 4 is 2. And then 2 goes here. 2 minus 2. This is 2, right? Oh, let me see. So this is 6 minus 3 is 3. That's correct. 3 minus 3 is 0. 2 minus 2 is 0. So these are updated. And 0 goes here. And then 13, 11. This is correct. This one takes from both of these. They take the minimum, which is 2. How about 11 minus 3, 8? So between these two, which one goes here? The lowest, which is 2. That's correct. And also, we have from A, this is lowest. That's correct. Okay, so this is updated. Let me save this. And what was the cost? So let's calculate the cost. So we did, initially, we did 1 time for A. So up to this point, it's 2 times for A. So 2 weeks, 2 weeks A, and 1 week D. These are crashed, right? Crashed 2 weeks of A and 1 week of D. So that cost would be 2 times 750, is that right? 750 plus 1 time $1,000. So 750 is 1,500. That's $2,500. $2,500. So we could crash. The goal, and the manager of this project asked us to crash this by 2 weeks. That was the here. Reduce project completion time by 2 weeks. So we did in 2 steps. Did it crash it by 2 weeks? From 15, it dropped to 13. And the cost was, because we did two crash on A, $750, that's the cost of it. And one time D, we did D, $1,000. Together, $2,500. All right, so I did put the network here. You can see that the network is pretty much the same as what we have. So A, the predecessor is nothing, so that's correct. B, nothing, that's correct. And then C has A, C has A, D has A, E has B, E has B, F also has B, F has B. So this part is correct. The next is H and G. So H has D and F. H has D and F, the two in the middle. I connect them to H. And G has C and E, C and E. That's why I put them outer of the network, because they both can connect to G. Okay, so now we put the numbers in, and the numbers are right here. I start A with the 5. How long it takes to complete activity A? 5. Starting at 0. 0 plus 5, 5. 5 plus 2, 7. D has 2 days. 5 plus 2, 7. How about E and F? E and F for B. B is 8. 8. 0 plus 1 is 0 plus 8 is 8. And then 8 is here. F is 7. 8 plus 7 is 15. 8 plus 5 is 13. So E is connected to G directly. So the 13, between 13 and 7, which one I chose for G? The maximum. Maximum between 7 and 13 goes up here, 13. 13 plus 11, 24 on the green part. And for D and F, they are both connected to H. So between 7 and 15, which one I take? I take 15 because 15 is the maximum. Maximum goes up here. 15 plus 6 is 21. There is no connection between G and H, so that's end of the network for H and end of the network for G. So we have two ends. Remember, whenever we have two ends, the backward process starts with the maximum of them. Which one is higher? 24 and 21. 24 is higher, so moving backward, I put 24 here, and I put 24 here as well. Both have 24 because backward process start from the maximum it takes to complete this project. Okay, so moving backward is also as simple as what we started earlier. So let's see, 24 minus 11 is 13. And then do I put 13 here too? Yes. Another 13 goes here. 13 minus 2 is 11, so I put 11 here. And 13 minus 5, and also we have 8 here as well, because that 8 goes here. 8 minus 8, 0. That's a 0 here. And then, which one? 13 minus 2, 11. So put 11 here as well. 11 minus 5 is 6. That's a 6. This is correct. How about this one? 18 minus 7. And that's correct. And this one. So we have 18 here. There, 18 minus 2 is 16. Okay, check your numbers. They all seem to be correct. All right, so this is our next example. And in this example, we have a crashing problem. We're crashing a network. So the network is given we have to create the network. We have to calculate the forward and backward processes, find the critical path, and after that, do the crash. And how do we perform the crash? It's saying crash the project to reduce its completion time by 2 days. So whatever the completion day comes out after creating the critical path, we want to crash it by 2 this is weeks. Okay, and then and at the end says what is the total crashing cost? Of course, the minimized cost. So we can see we have the activities A to F, duration, which means how long or how much time it's going to take, how many weeks it's going to take for each activity to complete, and the presets. That means, for example, B and C, they have to wait for A to complete. E has to wait for B to complete. F has to wait for C to complete, and also wait for E to complete. Okay. The crashing costs are also available. Remember that for the crashing process, we need to find the critical path first. After knowing the critical path, the next step for us is going to be finding the lowest cost on the critical path and then crash. So looking at the persist, we can see that B and C are going to start to work and process after A completes. E waits for B. F waits for C and E, both of them. Then we plug in the numbers. So I copied and pasted the table here, so we can really quick put numbers. So A, it takes 3 weeks. So 0 plus 3, 3. So we're filling up the top part first, and backward will be filling up the lowest part. So 0 plus 3 is 3. 3 goes here, and 3 goes here as well. 3 plus 2, 5. 3 plus 4, 7. 5 goes here. 5 plus 1, 6. And here, 3 plus 4, 7. Now, 2 nodes are connected to F. Which one do we take? We take the maximum. We take the one that is higher. So between 6 and 7 on top, I take 7. Because between E and C, the F has to wait for both of them to complete to continue, right? To start its process. So which one completes later? C completes later. So 7 goes here. 7 plus 3 is 10. So the maximum time it takes for us to complete this project is 10 weeks. Now we're moving backward. Backward process starts with 10 as well. So 10 is copied here. 10 minus 3, 7. 7 goes here. 7 minus 4 is 3. 3 minus 3 is 0. On this side, 7 goes here. 7 minus 1, 6. 6 goes here. 6 minus 2 is 4. Now we have to check the critical path. So this is our critical path. Why is that? It's because 10 minus 10 is 0. 7 minus 7 is 0. 3 minus 3. You can also check the left-hand side. 3 minus 3 is 0. 7 minus 7 is 0. So this is critical path. Now, next step, you want to crash. So these are the costs. On the critical path, between A, C, and F, which one has the lowest cost? C and F, which one has the lowest cost? C is 200. B is not on that critical path. B is here. E also is not. So after those, 200 is the lowest. So we're going to crash C by 1 week. So 4 reduces to 3, and we recalculate everything. So 4 reduces to 3. 3 plus 3 is 6. So I recalculated everything here. 3 plus 3 is 6. And then 6 goes here. 6 plus 3, 9. So 1 day has reduced. And backward process completes everything. 9 minus 3, 6. 6 minus 3 is 3. 3 minus 3 is 0. And here, 6 goes here. 6 minus 1, 5. 5 minus 2, 3. 3 minus 3 is 0. Okay, now this doesn't always happen. In this case, it happened that now we have two critical paths. Because 5 minus 5 is 0, slack times are all 0. 0, 0, 0, right? So one critical path, two critical paths. Remember, the method says when you have multiple critical paths, you must crash on each critical path and crash the activity with the lowest cost. So let's look on the top part, A, B, E, F. On A, B, E, F, A, B, E, F, the lowest cost is B. B is $110. So I will crash B by 1 week. So that 2 reduces to 1. 3 plus 1 is 4. And on this side, on ACF, I would crash C by 1 more unit. So 3 plus 1, I'm sorry, 1 more unit, that would be 2. So 3 plus 2 is 5, and that goes by 5. So let's see. This reduced to 1. 3 plus 1, 4. 4 plus 1, 5. 5 goes here. 3 plus 2, 5. 5 goes here. 5 plus 3, 8. You can see from 10, we came down to 8. And the goal of this crashing project was to reduce by 2 weeks. And we did by 2 weeks already. We just need to recalculate everything and make sure everything is correct. So 8 minus 3 is 5. 5 is here. 5 minus 3 is 3. That's correct. 8 minus 3 is 5. 5 minus 1 is 4. 4 minus 4 goes here. 4 minus 1 is 3. 3 minus 3 is 0. Right? And we have achieved the goal or what is ordered by our manager. Now it's time to calculate the total cost. To calculate the total cost, we need to see how many activities we have crashed. We crashed 1 time C at the beginning, and 1 time B, and 1 time C. So two times C is crashed, and 1 time B is crashed. Just plug in the cost. 2 times C, C costs $200, and 1 time B costs $110. Just calculate that, and that would be in dollar and dollar. Total is $510, and we could crash 2 weeks from 10 to 8 weeks.